I am very excited about today's video. Today, I'm going to reintroduce you to some friends that you have forgot about. In Algebra 1, you learned about some factoring methods. We're going to call those our factoring friends. And back in Algebra 1, you used them to help you factor quadratic expressions. So I'm going to reintroduce you to your factoring friends, and you're never going to part with them again. You're going to use them as long as you're in a math class. Your essential question is, what are some factoring methods? Again, we'll call those our friends. And how do you use them to factor expressions? And I call these factoring methods our friends because we go to them all the time and we ask them for help. We hang out with them a lot. First, I'd like to review a little bit of vocabulary. When we multiply factors, so factors are two numbers or three numbers, two or more numbers that are getting multiplied. And when you multiply those factors together, you end up with a product. So for example, in 4 times 5 equals 20, the factors are actually 4 and 5, while the product is 20. So the numbers that are being multiplied together are your factors. Your product is 20. So let's recall multiplying polynomials. In our last lesson, we were multiplying polynomials, which was basically all we had to do was distribute. We took every term in the first polynomial and multiplied it to every term in the second polynomial, and then we combined like terms. And sometimes we had a special case. For example, if we had a binomial times a binomial, then we could use a process called FOIL, first, outer, inner, last. For example, when multiplying these two binomials, if I multiplied the first terms, I would get 14x squared. Multiplying the outers gave me negative 10x, and multiplying the inners gave me 21x, and when I combine those, I get my middle term of 11x. And then multiplying the last terms gave me the negative 15. So this matches the product that we're given. Now today what we're going to do is we're actually going to be given the product, and we're going to want to go back to the factors. So it's the reverse of what we were doing in our previous lesson. Now these can be applied to area models. So in this area model, in this image down here, we're actually given a rectangle, and we are given variable expressions for the side lengths. Well, we know that area will be length times width, or base times height. And in this situation, let's call my length x plus 3, and my width x plus 5. And I can FOIL this because it's a binomial times a binomial. So my first, I'll skip a little space, will give me x squared. My outers give me that 5x. My inners give me 3x. So altogether, I'm left with a middle term of 8x and a last term of 15. Now notice where each of these come from. The x squared came from actually just focusing on this big square with a side length of x and x. I got x squared, right? And then the 3x and the 5x came from multiplying. Well, we have a length of 3 here and a length of x here, so we got 3x. And the same thing down at the bottom where you have a length here of x and a length here of 5. And then the last rectangle here came from having a side of 3 and a side of 5 to give us 15. So that's another way of looking at it. So altogether, the area of this rectangle can be written as a quadratic expression, x squared plus 8x plus 15. All right, so again, now you'll be given the area of a rectangle, and you'll need to get back to what are the side lengths of this rectangle. All right, so you need to get back to the factors. So we are going to be factoring, and this is where your factoring friends are going to come in handy. So I'm going to give you 5 factoring friends today. These are basically methods. I like to call them factoring friends because you always use your friends to help you out. And I would recommend going through your friends. Every time you have to factor a quadratic or any kind of expression at this point, you're going to go in to your friends and you're going to ask each one of them for help. So for example, friend 1 is your greatest common monomial factor. Monomial means one term. Okay, monomial, one term. So in example 1, I have a trinomial. I'm going to look at every single term. I'm going to ask my first friend, hey, greatest common monomial factor, can you help me out? In other words, do all three terms here in this expression have a common factor that I can factor out or undistribute out? And in fact, they do. They all have a 5 in common. So I would undistribute the 5. And then to get the remainder of what's left, I'm going to think to myself like I'm undistributing. So 5 times what gives me 5x squared? X squared. Because if I distribute those, I get 5x squared. And 5 times what will give me the second term of 10x? That's right, I need a positive 2x. And 5 times what will give me my last term of positive 35? I need a positive 7. So now I have factored or undistributed in this case. So I have two factors here. The first factor is 5, and the second factor is the trinomial. Those two things now I could redistribute, and I would get right back to what I started with. But this is the factored form. This is what you're hoping to get to. So let's do that with example 2. So now I have 4 terms. I have a quadrinomial. Looking at each and every term, do they have something in common? Is there a greatest common monomial factor? And if so, you want to factor that out first because it's going to make your life a lot easier. So always hit up friend number 1, see if they can help you. All right, friend number 1, is there a greatest common monomial factor in this quadrinomial? Well, just looking at the coefficients, 3, negative 21, 27, negative 18, they all have a 3 in common. So I'm definitely going to factor out a 3. Now, is there more? Let's see, looking at the x parts or x factors, x to the 5th, x to the 4th, x cubed, x squared. As a matter of fact, they have x squared in common. So I can also undistribute an x squared. And how about the y's? What's the most amount of y's that they have in common? It looks like it's a single y. Okay, so that's my greatest common monomial factor. And I'm going to undistribute that. So I'm going to ask myself 3x squared times y times what will give me this 3x to the 5th, y to the 7th. Well, I don't need a coefficient. A coefficient of 1 will totally work. I need x cubed, and I need y to the 6th power. Because x squared times x cubed, if you have those like bases, you add your exponents. That gives you x to the 5th power. And y, that's really y to the 1st power. Y to the 1st times y to the 6th. Well, you add the exponents when you have like bases and you're multiplying, and you get y to the 7th. Next term. What am I going to multiply by to get this negative 21x to the 4th, y to the 5th? Let's break it up by coefficient first. So 3 times what gives me negative 21? That's right, negative 7. All right. X squared times what will give me x to the 4th? All right, well, we're going to do x squared because x squared times x squared is x to the 4th. Okay, and then y to the 1st times what will give me y to the 5th? Y to the 4th. Moving on to the third term, right over here. So what am I going to multiply 3 by to get the 27? Positive 9. X squared times what gives me x cubed? X to the 1st. I'll just write x instead of x to the 1st. And y to the 1st times what will give me y cubed? I need y squared. All right, and then the last term over here, well, 3 times what gives us negative 18? It gives us, we need a negative 6. X squared times what gives me x squared? Oh, I don't need any more x's. And how about the y's? I don't need any more y's. So there it is. Now that's completely factored. I have no more common monomial factors in this grouping of 4 terms. I have factored out the greatest common monomial factor of 3x squared, y to the 1st. And I have rewritten it as a product of 2 factors. That is your first factoring, friend. Every time that you need to factor, please ask greatest common monomial factor for help. Always, always, always look there first. All right, friend 2 is difference of two squares. Now this one is really obvious. If you have a binomial and you have two terms, and each term is a perfect square, meaning you can take the square root of it, and there's a subtraction sign in the middle, then you have a difference of two squares. This is a difference of two squares. And when you factor a difference of two squares, it results, and this should look really familiar to you, this is what we call the sum and difference pattern. All right, so let's put this to practice. First of all, don't forget about your first friend, okay? So if I have a difference of two squares, that's great, but I should always, always, always look at my expression and say, is there a greatest common monomial factor that I can factor out first? And in example 1 here, there is not. Next, I look at it and I say to myself, it's a binomial and it's got a subtraction sign in the middle, and my two terms are in fact perfect squares, meaning I can take the square root of each of these. And if I think of it as some base squared, this is x squared and this is 5 squared. So this in fact is a difference of two squares. All right, so you're going to take those two bases, the x and the 5, and you're going to write them in a sum and difference pattern. So we'll have x plus 5 and x minus 5. And you can always check these by redistributing or refoiling, right? So if I wanted to check this to make sure that I was getting it right, well, look, you've got your first terms multiplied to give you x squared. Your inners and outers are actually opposite of each other. Look at this. Inners give me 5x. Outers give me negative 5x, right? So inners and outers go away. And then my last terms give me negative 25. So it does check out. So the factored form of x squared minus 25 is the product of two factors, x plus 5 and x minus 5. They're binomial factors. All right, example 2. Don't forget about your first friend. Greatest common monomial. Can you help us out? Do we have a greatest common factor between 16x squared and 100y squared? And in fact, we do. We could factor out a 4. So I'm going to do that now. Now, when I do that, I have a 4x squared left minus 25y squared. Now, we're not done. What I notice is that this part right here is a difference of two squares, right? So 4x squared can be rewritten as 2x to the second power, right? The base 2x is being squared. Or in other words, the square root of 4x squared is 2x. Okay, and then 25y squared can be written as, well, 5y, the whole thing squared, and subtract those. I'm actually going to move down here. All right, so when I factor this, I'm going to keep the 4 on the outside. And now I'm going to use my 2x squared and my 5y squared, those two bases squared, to put into my sum and difference pattern. So I'll have a sum pattern and a difference pattern. And again, it's just the square roots of the first and second term. Or in other words, these bases here, those are kind of like your A and your B in the pattern. So we'll have 2x plus 5y and 2x minus 5y. So this is completely factored. Now, how could I check that? And this is where you want to recognize you have a binomial times a binomial. And so if you just try and FOIL that real quick, right, your first terms will give you 4x squared. Your inners and outers, look what you have. You got 10xy minus 10xy. Those cancel out. Your last term is going to be negative 25y squared. And then I've got that 4 that can be multiplied to this whole quantity. So then if I distribute that, I end up with 16x squared minus 100 squared. You can check all of these to make sure that they work out. And this one does. So your factored form now, this is a product of 3 factors. 2 of them are binomial factors, and one of them is just a 4, or like a coefficient. Moving on to the perfect square trinomial. The perfect square trinomial is a trinomial where the first term is a perfect square, the last term is a perfect square, and if you took the square root of both the first and the last term and you multiplied them together and you doubled them, you got the middle term. Now you are familiar with seeing it in its factored form. So this is the factored form, and we called that a square of a binomial. Because remember, when we squared a binomial, we didn't just square the first and the last term. There were inner and outer terms to be reckoned with. So we took a plus b and multiplied it by itself. And yeah, the first terms gave us a squared, but remember you got inners and outers, both of which were a times b, which meant that you had a middle term of twice a times b. And then your last terms were b squared. And then the same would be true if you had a negative middle term. Then you would just have the square of a binomial that was a difference of 2 terms. All right, so let's apply this. So first of all, we'll always look for a greatest common monomial. In example 1, I do not see a greatest common monomial. However, I do notice that the first term is a perfect square. It is x squared. If I take the square root of x squared, I just get x. And I notice that my last term is also a perfect square. It is 5 squared, written as a perfect square, or if I took the square root of 25, I would just get 5. So x is my a in this situation, and 5 is my b. Now, if I take 5 times x, so I'm just kind of thinking about this in the back of my mind. If I take 5 and x and multiply them together, I get 5x. And if I double that, like this formula says, well, I get 10x. Notice that matches this middle term. So I can conclude that this, in fact, is a perfect square trinomial, which means that when I factor it, I am just going to have a binomial that I am squaring. Great. So now I'm going to use a and b, or the square root of the first term and the square root of the last term, so x and 5. And the sign that goes in between them is this sign right here. And again, I can double check this, like go off to the side. Multiply x plus 5 times x plus 5. Just like we did in our last lesson. Double distribute or FOIL or however you want to think of this, but you get x squared. Inners and outers are both 5x. Double that, you get 10x. And the last terms are 25. So in fact, it does check out, right? So you can distribute, you can FOIL, and you double check. Okay, so the factorization of that trinomial is the square of that binomial. Example 2, let's see. There are a couple ways I can work on example 2. However, I'm going to remind you, anytime you start to factor, please look for a greatest common monomial. It's going to make your life a lot easier. So I go to friend 1, greatest common monomial, can you help me out? And in fact, they can. 16x squared, negative 80xy, and positive 100y squared all have a common factor of 4. So the first thing I'm going to do is factor out a 4. And that's going to leave me with 4x squared minus 20xy plus 25y squared. So now I look at the trinomial that's left and I ask myself, well, there's no more greatest common monomials. It's definitely not a difference of 2 squares. I wonder if it's a perfect square trinomial. Since it is a trinomial, the first term can be written as 2x squared, right? Take the square root of 4x squared, you're going to get 2x. The last term can be written as 5y squared, right? Square root of 25y squared is 5y. And then I wonder if I take this 2x times this 5y, Well, that gives me 10xy. And what happens if I double that? Well, if I double that, I end up getting 20xy, which happens to match my middle term. So this, in fact, is a perfect square trinomial. So I am going to factor it as the square of a binomial, keeping my greatest common monomial that I factored out. That's a very important part of this. It's actually like a vertical dilation factor. It tells us how tall this thing might be. All right, so I'm going to square a binomial. I'm going to put my a and my b as my two terms, or the square roots of the first and the last terms. Those will be the two terms in the binomial. And then what sign should I use? Well, I'm going to use the sign of my middle term. So again, I can check this. I just come over here off to the side, keep the 4 out there. Let's go ahead and multiply 2x minus 5y times 2x minus 5y. And then you FOIL that or you distribute that. All right, so let's see. 2x times 2x is 4x squared. 2x times negative 5y, negative 10y. I'm doing it a different way just in case if you don't remember this, but we did this in our last lesson where we were multiplying polynomials. Negative 5y times 2x. Oops. Sorry about that. When I did 2x times negative 5y, I should have gotten negative 10xy, not just y. And then when I do the negative 5y times the positive 2x, well, again, I'm going to get the negative 10, and I'll put it in the same order, xy. And then my last terms, they are going to give me positive 25y squared. Let's combine like terms. I'm going to end up with 4x squared minus 20xy plus 25y squared. Now distribute the 4. You're going to get the 16x squared minus 80xy plus 100y squared that you started with. I can double check that my answers are correct every time I do these problems. I can even make sure I do it right on the test. So the correct factorization of our original trinomial is the square of a binomial being multiplied by our greatest common monomial of 4. I think today we're just going to leave it with those 3 friends. In class, we'll practice and master working with those 3 friends, and then in your next video, I'll cover the last 2 factoring friends.